Hey, welcome back. This is going to be another video where I continue the recreation of the CBR600 F4's wiring diagram. I'm doing this in KiCAD. Again, this is not a KiCAD tutorial, but I'm going to just be utilizing it for its circuit building software. From the last video, if you watched it, you'll remember this component here where we went over how the battery will supply power for the starter motor as well as send some power elsewhere. And I labeled this as a power junction, but actually after reviewing another schematic, I found out that this is actually just the keyed ignition. So where you'd go and turn your key to turn on like your lights or to allow for ignition to go. So I'm gonna change that just so I know what it is. The next thing that I want to get into is what happens after we have that ignition turned on. We know that the fuses get their power, and that's here. So the key will allow those circuits to be powered. And then afterwards we get to this engine stop starter switch. So this is where you'd actually start the car, and I'll just go ahead and get right into building that in the diagram on the handlebar section. So the front brake light switch is just a simple switch. When you press the button, it closes. When you're not pressing the button, it opens, and this is just activated by your front brake lever on the right side of the handlebar. And this would just allow the lights on the back of the bike, the brake lights, to illuminate. This other section, this engine stop start, is a little bit more complex. We have three main circuits. We have our ignition. This is just a normally closed switch here that will stay closed, and this is just to provide power for everything that needs ignition. This is the one that if you were to press the reset, like the emergency stop, this one would open. The second set here we have ST. This is meant for starter. So this is when you if you close the switch here and ignition is on, that means this black and white wire has voltage applied to it. If you close this switch, that will send the signal from YR to that solenoid, and that solenoid is at the starter motor, and that will allow you to start the engine. Black and yellow wire is the power wire for both the ignition and the starter, for the starter solenoid. If we scroll over just a little bit here, we see that this black wire coming out of here eventually will come back around into this connector here, where this black terminal turns into a black and yellow, and that provides the power for that. And then when ignition is turned on with your key and the reset switch pressed, this black and white will then allow all the power to work. So as soon as you press that reset switch, it turns it all off. I'll get started on the left hand side of the handlebars, which will be down here, and this is where we have our headlight circuit, our signal circuit, and our clutch switch. So let's get that. Okay, so let's just take a break and kind of discover what we've been dealing with here. So I've created the switch circuit on the left-hand side of the handlebar, as well as the clutch switch circuit component here. If we go down here, we can see the clutch switch is here, the horn circuit's here, and that's connected to our horn thing here. So I'll start off with the horn. We see that there's a light green and a blue and brown wire. And when you press the button in, and that's what this little structure here is supposed to be, it's going to connect these contacts. There's going to be a metal piece on the bottom here, so that current can travel through that and back out through the light green wire. When that happens, the horn will just go, just much like a speaker, and it will be grounded through this green wire. The clutch switch here is much like the front switch for the brake lights, where if we press the clutch lever, it's going to allow the current to go through. However, we don't have a light circuit at the other end of this, so let's figure out where that goes. we have a black wire here and a black wire here. If the contacts are closed, we're going to see that current travel through the black and white, or the voltage anyways. It will get transferred into this green and red wired circuit. And if we follow that all the way up, we get to this part called a diode. Now a diode, if you don't know, is just thought to be like a one-way valve for voltage or current, meaning that we can send voltage this way or current through this way, but we can't go back out through this way. So similarly, we could come in through this light green and red, but it wouldn't go through and back into this green and red. It would just send signal through this light green wire. So if the green and red one is for the clutch switch, meaning this light green wire is going to know that our clutch is switched if it's pressed. And then on the left side, if we take a look and we reference this as a light green and red wire, and remembering that no matter where you are in the circuit, if the conductor is the same color and has the same color legend, it's the same signal. So what that means that this light green and red wire is our neutral switch. Our light green will receive a signal if either our neutral is engaged or if our clutch is engaged. One or both of them have to be engaged for us to start the vehicle, and that's how that is dealt with here. So let's head into the headlights. Now our headlight circuit here, we have a blue and white wire, and this actually just came from our start-stop switch. We had a blue and white, so whenever we're not starting the car, we're going to see our headlights receive power through the blue and white. So that's always available. Now on a bike, you'll always have either headlights or high beams on. So that's what this indicates here. Now as you toggle that switch, you'll either turn from the low beams or the high beams. The next switch is probably the most complex on the left-hand side of the handlebars, and that's going to be our turn signals. We see that there's an orange with white stripe, we have an orange wire, we have a light blue, and a light blue with white stripe. So this is very common when you have circuits that are very similar, but they're not the exact same. So the odd ones out are this green wire, which I actually put a GR instead of just a G, but I meant to say just green, which is typically used for ground, and we actually saw that on our horn circuit that this was connected to ground. So we can also assume that green is just the general color for ground for this diagram. So I'll put that here on this side. And the reason why I'm putting it on this side is because we see this notation of PL and PR, which I could assume as being power left and power right. What that means is that this blue and brown wire is probably the power. If we actually come over here to fuse C, we see that there's a blue in our brown wire, and we know that our fuses are at the power end of the circuit, so we can safely assume that blue and brown is going to be the power side of our signal circuit. So now we have this switch that can it's almost like wiper blades. It can either go left or it can go right. But if we move this to this side so that this switch is on the orange, that must mean that this blue and brown will then have our switch connected to this light blue and white. So that means that one ground side of the circuit is connected while the other power side of the circuit is connected. If we want our left signal lights on, we're going to switch the switch to the left side. That will allow our light blue and white wire to have power, but then that will ground our orange wire. Only one signal light can be on at one time. If we move that switch the other direction where our PR was receiving this switch here, that would mean that our light blue was receiving ground. I'm going to go ahead and move these back into position, and then I'll get started on that diode circuit. Okay, so that's about it for this video. On the right hand side of the screen, that's what we've put together today. We've recreated the engine stop-start block that's on the right hand of the signals, or on the right hand of the handlebar, and on the left hand side of the handlebar we have our clutch switch, our turn switches, our headlights, and our horn. We see that our horn is just a simple push button switch that allows it to turn on. Our clutch switch is very similar to our front brake lights in that you just press the levers and it will allow current to go through. However, our front brake lights will provide power to a light circuit, and our clutch switch provides power to this circuit here, and it will allow us to tell the light green wire if either our neutral is engaged or our clutch switch is engaged, one or both of which have to be engaged for us to be able to start the car or the bike. Our headlight circuit is a simple toggle. Either we're going to be toggling our low circuit or our high circuit, but both will be engaged so long as ignition is turned on. And that's done through over here. Also, if ignition is turned on, that will allow us to start the car or start the bike. But this power only goes to the starter switch if ignition is turned on, and that's why you need a key to start the bike. From there, it just goes to that yellow-red wire, which you saw from the last video, that will go towards the solenoid, allowing the circuit to be completed over there and engaging the starter motor. We have various powers that are going to branch off from both of these circuits, and we know that those all started from these fused circuits, which everything is fused in the circuit, and previous to this, we saw that this distribution block was actually our ignition cylinder. So when you turn the key, it allows certain voltages from our battery, R, to be redistributed and fused and used for other components. In the next video, I'll branch off into lights. I'll probably deal with the front lights and the rear lights in one go, since we've already had a little bit of an introduction into how those circuits work. So thank you for watching, and if you have any suggestions, please feel free to comment or tell me what I can do better. Thank you.